Hi there. Today what we're going to do is we're going to look at some of the word problems and how to solve word problems. Now there's 3 techniques that you're going to use to solve word problems. I'm actually going to use an example that is with the PowerPoint provided with the book. That way we can get a really nice graph and the lettering and everything looks really nice. So I'll just run through this example and show you how to set up a word problem and what the different terminology is and what it all means. Now you can solve a word problem in 3 different ways, and it's usually good to use a couple of different ways. That way you can verify your answers. There's a numerical technique, which is just using data points and looking at tables of values. There's a graphical approach in which you take these numbers and these data points and you draw a graph based on your data. Next is to get an algebraic equation or formula, and using your rules of algebra, you'll solve for whatever particular quantity that you're looking for. All right, here's an example by the Metropolitan Life Insurance Company, and it involves an equation that they actually use to determine recommended weight for men. And this is the recommended weight for men who are 25 to 59 years old, meaning that you don't want to use this particular formula if someone is, say, 65 or 18. They would have a different formula, and believe me, they have formulas for everything. So this particular formula is used to calculate this recommended weight in pounds for men with a medium frame. Now also notice that your Y is in pounds and the X is the man's height in inches. It also states that this formula only works for X in between 62 inches tall and 76 inches tall. So anything above or below that, this formula really doesn't work for. They're first going to construct the table of values that's going to show what these recommended weights are, and they're just picking heights that are 2 inches apart in between 62 and 76, just to get a nice set of data points. And the next thing we're going to do is look at a table of values for these. After we get a table of values for these, we're going to use this data to sketch a graph. And then with the graph, we can, say, get the recommended weight for someone that's in between those heights. We're going to choose 71 inches because that's what they've asked us to do. Then we will plug that 71 into our algebraic equation that they've given us to confirm it and see how this compares. Now here's our table of values. We can get this table of values by either plugging them in independently into the formula, plugging in a 62, then a 64, and then a 66, and so on. Or you can use your calculator and the table of values function on your calculator. Now you can find out how to use this under course materials in the calculator info section. But if you look at the top of your graph, you'll see, or the top of your calculator, you can see where it says y equals. What you'll do is enter your equation into y equals, and then you can use your table set function to just read these numbers right off of your calculator, because it has to do this calculation in order to plot a graph anyway. Now here's the data points plotted. They're plotted on this graph. You can see them right here. We've got the height in inches along the x-axis and the weight in pounds along the y-axis, that corresponding to our x and y values. We would like to know the height at 71 inches. So what we will do is we'll just draw a straight line up from 71 inches and then go all the way across and figure out where it is on the y-axis. Now it looks a little bit above 160 and not a whole lot over. You might say 161, 162, keeping in mind that on a graph you're not going to get an exact answer. What you're going to get is kind of an estimate, and it always depends on what your scaling is on your graph, how accurate you are on your graph, how straight your lines are. So we won't get an exact value from a graphical analysis, but we'll get a pretty good estimate. We're going to say it's about 161 pounds for a 71-inch male. Now plugging the 71 into our equation, we plug the 71 in wherever there was an x, because our x is our height, and we're plugging that in for x. So this is our answer when plugging it in. You can see that we get 160.7, which is pretty good because we said it's about 161, 162, so it was a pretty good estimate of what the height weight correspondence would be of our male. The main thing on solving these is just to make sure you're very clear on what your x is, what it represents, and what your y represents. Look at your equation, or when you create your equation, always try to list out x is this, and state it in words. That way you can be clear, and also state in words what y is so you can be clear, and it is very helpful in determining exactly what it is you're supposed to plug in and where. And that's it for our applying techniques with graphical, numerical, and algebraic analysis.